In this lesson, we're going to begin learning about exponents and scientific notation. And these are the objectives for this lesson. If you'll add them to your notes, please, you can pause the video and then start back up when you're ready to go. First of all, we're going to learn about the product rule. If m and n are both positive integers and a is a real number, cannot equal 0, then when you're multiplying these by each other, you will actually just add the exponents. So if we've got a base of 3, and we've got 3 to the second times 3 to the fourth, it is the same thing as 3 to the 2 plus 4, or in essence 3 to the 6th, which is 3 times 3 times 3, etc., or 729. We have z to the third times z to the second times z to the fifth. That's z to the 3 plus 2 plus 5, or z to the 10th. We just add those exponents together. This one's a little different. We're going to multiply our coefficients, 3 times negative 12, and we're going to group our variables together. So we have y to the second times y to the fourth, which is the same thing as y to the 2 plus 4. So 3 times negative 4 is negative 12, and 2 plus 4 is 6. 0 exponents, any base to the 0 power is going to equal 1, but a cannot equal 0. So 5 to the 0 power is 1. This is the same thing as x to the 0, y to the 0, z third to the 0, which would be 1 times 1 times 1, which would be 1. A negative x to the 0 is the opposite of x to the 0, which would be a negative 1. The quotient rule also requires that a not equal 0, and what we do when we're dividing is we actually subtract the exponents from each other. We're going to group our coefficients together, place our a's together and our b's together. That makes it easier if we group the common bases together. 9 divided by 3 is 3, 4 minus 1, and 7 minus 2, which will give us 3, a to the third, b to the fifth. Negative exponents. If a is a real number other than 0 and n is a positive integer, then a to the negative n is 1 over a to the n. Notice that when a factor containing an exponent is moved across this fraction bar, the sign of the exponent changes. 3 to the negative 2 is the same thing as 1 over 3 to the negative 2, which is 1/9. 2x to the fourth. Now notice that 2 is not to the negative 4. X is to the negative 4. So be very careful. There's no parentheses grouping this together, so the 2 does not move along with the variable. This constant will remain in the numerator. So it's 2 over x to the fourth. That is a common error, so watch out for that one. Now for scientific notation. In many fields of science, we encounter very large or very small numbers. So scientific notation is a convenient shorthand for expressing these types of numbers. A positive number is written in scientific notation if it is written as a product of a number a, where a is greater than 1 and less than 10, and an integer power r of 10. So a times 10 to the r is how you'll see it written in scientific notation. Writing a number in scientific notation, you'll also find these steps listed on page 261 of your test, or your text. You're going to move the decimal point in the original number until the new number has a value between 1 and 10. You're going to count the number of decimal places the decimal point was moved in step 1. If the original number is 10 or greater, the count is positive. If the original number is less than 1, the count is going to be negative. Then we're going to write the product of the new number in step 1 by 10 raised to an exponent equal to the count in step 2. I know that sounds difficult. Let's put it in practice and straighten this up a little bit. We have 4,700. Well, we're going to, in order to make this a number between 1 and 10, we're going to have to move the decimal over 3 places to the left. so that that new number has a value between 1 and 10. Since we moved the decimal 3 places and the original number was greater than 10, our count is positive 3. So we can rewrite this as 4.7 times 10, and we move the decimal 3 places. Well, we've got a number that's smaller. So we have to move the decimal places 4 places to the right to make this a number between 1 and 10. It's smaller than 1, so our count is going to be negative. So we moved it negative 4 places. Now let's write scientific notation into standard form. So we're going to move the decimal point the same number of places as the exponent on the 10. If the exponent's positive, we're going to move the decimal to the right, and if it's negative, we're going to move the decimal to the left. So this is written in scientific notation. We're going to have to move that decimal point 3 places to the right. So our new number, 5,273 and 8/10. So the 8's still going to be to the right because we were told we're only moving it 3 places. Oh, this is to the negative 5, so we're going to move that decimal to the left. So it's at 6.45, so we're going to have to add 4 zeros before we place our decimal. 1, 2, 3, 4, because we moved it 5 places, and the 6 was already to the left of the decimal. Okay, you're ready to begin your practice.